Hello, Mads. I agree with you. Trying to explain things via email is difficult, but then I figured you can't get away with holiday homework that easily. So I thought I'd show you how to do it via video. Firstly, look at these two equations. These are our two equations for nappies. Here is disposable nappies, and here is cloth nappies. Now, on our y-axis when we graph it, is going to go cost, and then here will be our x. So going to our calculator, we can put in the first equation. So remember, our first equation was c equals 54m. And in our case, c is the y-axis. And f of x, this thing here, is our equivalent of y, so we leave it and write 54x. And that leaves us a very, very steep blue line, which can be made to see more easily if we change this number here out to 48. The question says we should go on for 48 months. And this value here will be the total cost, and as nappies cost $54 a month and we're going out to 48 months, we should put that at, say, around $2,000, which sounds like a lot to spend on nappies. Alright, there's our graph. So starting at 0 and for every month going up $54. Alright, but now we want to enter the second graph as well. So the second graph was $320 plus $5 for each month. So we enter 320 plus 5x, x being the number of months. And we have a line that goes across like that. Now what this means is that we can find where they intersect. Menu, analyze graph, intersection. And our lower bound will be below the intersection, upper bound above the intersection. And they intersect where x is 6.53, meaning that after 6.53 months, the blue line will overtake the red line. What this means is that for the first 6.5 or 6.5 months, let's say, for the first 6.5 months, cloth nappies will be more expensive. And they're more expensive because it costs $320 to buy the cloth nappies in the first place. But then, each month, it only costs $5 to wash them. However, for disposable nappies, it costs almost nothing at the start. That's down here. But then for each month, it costs $54. And hopefully you can use that information to help you answer the questions below. Alright, now, the last page. I thought I'd have a go at one question. Hopefully you can use this example to go on from others. A deposit of $4,000 placed in a compound interest account at 11% per annum, compounding half yearly. Find how long it takes for the investment to double. Alright, so for these sort of equations, we use this equation. Now, if you go back in your notes, you'll find more detail on this. But essentially, we need to write down what everything is. The future value isn't explicitly told to us, but they say they want the investment to double. And if it started off being 4,000, well then the future value will equal 8,000. Present value is what it is at the start, which is 4,000. Interest rate is 11%. But remember, we're going to divide it by 100 to convert it into a decimal. And then we take that and divide it by 2 because we want the interest rate per period. So here it's being compounded half yearly. If it's 11% per year, we divide it by 2 to get it per half year. And finally, n is the number of compounding periods. And that's what we're trying to find. Alright. So what you'll need to do is put this equation into your calculator, and you'll say that, alright, 8,000 is the future value. That is equal to 4,000 multiplied by 1 plus 11 on 100 is 0.11 divided by 2. That's this 2 here. power of n. Now we can't solve for n algebraically, so what you have to do is use your solver function. You would write solver, then all of that in there, comma, n. You want to solve for n. And it will give you a value for the number of half-yearly periods required to solve for n. And that will give you an idea of how long it takes. So for example, if the number comes out as 14, you know that it's 14 lots of half years, or 7 full years. Alright, I hope this gives you a bit of a hand. I will see you on Monday.